would like to invite Geir up again, and our colleague here from our friend from the University College, Arne. Okay, so thank you very much for a lot of new information. I have to say that Christina and I, we did pretty much a tour of Norway and Scandinavia in 2004-2005 to figure out if MARSEC had any future in those countries, and the conclusion was probably not, because none of this was going on. So it's pretty much a revolution that has happened over the past 5 years. I think it was an acceleration. You said 10 years. That's probably since 2005-06. It has just taken off tremendously. Now, this is, as far as we see it, very much high-tech in the marine business now. How do you see it? Are there any aspects that you haven't showed us, or and what do you think will happen in the next 5 years? What will the high-tech drive be, apart from developing these systems further?
Good question. It's always difficult to look into the crystal ball, but what I do know is that all the major suppliers of the onboard systems in the region and Ålesund are all developing or looking into their own middleware. They're also all thinking of integrated bridges, integrated bridges concept, where they are looking much more into the user-friendliness and man-machine interface type of focus is absolutely in all of these companies now. So that's a big drive, and I expect to see a lot of new things coming out of that. And I also hope that we see a lot on the standardization side. It should be.
So what you're saying is that there's quite a lot of 80% duplication work going on in the different companies?
Even 90. Yeah, much. And I mean, that's the daily problem for us up with others. We seem to spend 80% putting together some kind of basis to build our actual logic on, over and over and over, especially in the maritime industry. And we have to get rid of that. I don't know what you get.
Yeah. We have a very conservative industry, we have conservative ship owners, and we also, well, I think that we have a lot of people out there who don't really want these fancy solutions. So, if you, for instance, take the DP, could be with our dynamic positioning system just do like this, shush, shush, and that means that you are going 3 meters forward for pipeline. Should pipeline be just like whoosh, whoosh, and so on? Actually, yes, I think these things we see here solve a lot of problems, but I still think that with huge complicated systems there needs more thinking. I have done this thinking already. I am working on a switch on IOOI, present how to use UML, state machines, etc. And to be able to understand the properties of large interconnected systems, working together with the university in Trondheim, the Institute of Telematics. So I think we have a lot of interesting developments there. Would like to come back and show later on. But I think that the conservative business should they will continue to be conservative, and they want to have solutions put into their hands so obvious that they cannot avoid seeing it. So, for instance, with a simulator, you can't avoid being impressed by it. And when you have come that far, people will begin to grab deep into their wallets because they want it.
To stir up a bit of debate, in a way, everybody is claiming that this business is very conservative, and in a way I can agree, but what we have found is that you have to, it's almost like different views in UML. You have to to present your case in different ways for different stakeholders. And the problem can maybe be stated like this, you know, the ship owners like Hasnes and all these guys, I would argue they're conservative because they're really quite risk-willing when it comes to technology, as long as it actually serves their purposes. So, for example, if we can argue that they're, you know, when these guys launch a new ship, say in 2013, they usually have it chartered out for the next 6 years full time. If these guys could have access to technology that could make it possible for them to do remote maintenance, upgrades on the fly, much fewer days not operational, they would buy a dividend because they see it from a financial perspective. They don't see it necessarily from a technology perspective. So we're not going to describe to them MARSEC technology-wise. We're going to describe the things of MARSEC. So I think that's a little bit, and you know, when you see the slides, I mean, I don't think they bought the X-File because it's cool, although it's cool, but I think they did it because it gave operational benefits. The other thing that we can see as a very big trend that we haven't touched so much upon here, but maybe have it in the cluster anyway, is hybrid propulsion solutions, diesel electric, LNG use, and things like this, because the fuel bill and the carbon footprint is of major concern. And we can see a lot of technology, onboard technology, and offshore or onshore technology coming into play there, because there is amongst owners, many of the more progressive ship owners, even in, for example, transportation business, they would like to actually monitor that the captain and crew are working in a financially optimized way. Currently, the gig is if you go from Korea to Europe with cars, the only thing that actually shows is that you come up on time. But nobody knows how much fuel you burn on the way, and there are big differences. And this is a concern. The land-based monitoring center would like to actually follow these things up. So in power generation, power consumption, we also see a high-tech drive in the future. Do you agree?
Yes, I absolutely agree. And there are already being research projects that I know between Marsden and Monsholm, where they're doing a lot of monitoring. So anything that they can monitor on an asset, they monitor. And what's really interesting from an operational point of view, from Marsden, is to see how much time does the vessel spend in transit from A to B, how much time does it spend on DP, how much time does it spend on doing anchor handling operations. Because that does give knowledge about how should the next vessel be designed, so that you actually utilize the use of the vessel combined with what you are talking about, the energy needs and the type of fuel that you want to power the vessels with. And also that includes the shore-offshore communication. And the ship owners can sit and monitor what's going on in the vessel. They can actually see in real time what modus is the captain operating the vessel in. Is it the best modus or is it not? Of course, the challenge is from the industry, the vendors that are to supply the high-tech DP systems, the high-tech propulsion control systems. And I've seen an early example where the captain had a choice of 6 moduses he could run the vessel in. So he had a button mode 1, 2, 3, 4, 5, 6. And each of the modes were sort of ideally combined between use of pitch and RPM, etc., to optimize the fuel usage and optimize the way you sail the boat. Now the captain, when he came on board, said, okay, I'll use mode 3. That was the best one last time I used it. I haven't got a clue what it does, but it works. And that just goes to show you that you have to do some major thinking of how you may make this available for the captain as is to do the decisions that will actually work. But there are a lot of stuff also going on that, yes.
Then we have, of course, our favorite topic of e-navigation. What role do you see in the offshore operations? Is e-navigation playing today? Is it, are there wishes for improvements? or is it something that is only used on board, or how do you see this?
Actually, I think there are so many low-hanging fruits for companies in the maritime industry. I think that there are zillions of ideas that we just need to put into working systems. There is so much, it's just to grab anything and work with either navigation, of course, make the infrastructure, it will come. And not only that, you will have so many other things to put on top of it. My little tinkering with the alarm system, it was a low-hanging fruit. And it will be in that way also, because of open source, it will be so much easier to implement so many things. There are, as I said before, billions of ideas, but people don't know how to put it into working systems in a simple and easy way. And that's why I, in addition to the open source, also promote models, principles, etc., standards. All those things work for us like they've done for other areas. And when I say that we are conservative, it's simply because we are, it might be because we are lazy or something like that, or because sailing ships pass much slower than aircraft. And so, yeah, it will come. I mean, it's so much money over there, it's unbelievable.
Being sea officers ourselves, Christina and I are actually, when we're out at sea, quite amazed about how often you end up on a collision course with something, despite the huge size of the sea. It just seems to be sort of clunking together in a way. So one very interesting experience. Yes.
I think it was in 1895 or something like that. There existed 4 cars. 4 cars have been built in that, until that. 2 of them were, I think, in Chicago at the same time. They collided.
That's right. We actually had a very interesting experience with the Danish Coast Guard via Skype. The other day we met the guy that we haven't met yet, but we had a long discussion about their Axis project, their e-navigation prototype. And he pointed out to us the importance of being able, from a vessel traffic control center, to actually put up dynamically no-go zones graphically on the map with high reliability, because it's virtually impossible if you sit in the Strait of Ålesund and you know that there is a Danish fishing boat that is without power drifting, and you have 5 ferries, 30 tankers, one Russian that you can't even get in contact with on radio, and you try to give them the coordinates that they shouldn't go to. But if they manage to put a red no-go zone on the map dynamically in these ships, the problem will at least not be sorted, but close to sorted. Now you mentioned actually offshore specialized operations. I don't know if you have any problems with this in Norway, where you have offshore, but I can imagine in the Med, where it's a lot of traffic, and oil and gas exploration starts, and you start to drag these platforms around with a number of tugs and so on. There can be very interesting situations because other seafarers may not even be aware of how close they can go to these and so on. So we would argue that proper navigation standards and so on can be very important for these operations.
I agree. I would like to just maybe divert a little bit. There was some mention about if we can learn anything from the airplane industry. And we had a large research project where we involved, as part of that project, some former pilots from the airline industry, and look at how emergencies could be handled, and look about checklists and procedures and how they handle crisis situations. And something that was quite interesting, just as a small example, was that in order for a pilot to be allowed to land a 737 in Ålesund, the airport in Ålesund, there are 4 things on his checklist, on the captain's checklist, that he has to check before he is allowed to land. Now, for an offshore vessel, when the support, for example, a supply vessel enters the 500-meter zone around surrounding a offshore platform, then there are procedures that tell you are not allowed anymore to run towards the platform with the bow. You have to turn around the ship. There are changeover procedures to hand over control from the forward bridge to the aft bridge. And the checklist that the captain has to relate to has something like 148 items, right? And they say it's just too much. You know, you cannot really evaluate all those things before you know. So I think we actually found out there is a lot to learn from the airline industry when it comes to, at least when it comes to procedures and how you handle crisis situations.
Maybe it's not related to the topic you spoke about, but first of all, I've introduced myself. I'm Adrian, or in English, Adrian Rutle. So I am associate professor at Ålesund University College, and I'm in this project which Arne talked about earlier. Been working mostly on onboard engineering and flow methods, and most people call me or some people call me for software guy, but I'm actually the modeling guy. So the question is back to you guys about MARSA. So how much modeling and remote engineering has been used in this architecture you're proposing? So is it any, I've been thinking about like high-level specification for architecture, or is it mostly just implementation?
We have actually, in the current version, we're using UML and different views and so on. This is something we're discussing now. Are we going to make it mandatory with one representation? Are we going to we try to be as concrete and usable as possible, but also independent of various things. So we would, if we have a new or a good model that we have used, we would try to be happy with that. We want to be front-end independent in the implementation and back-end independent. So basically, MARSA is going to be for the marine sector a domain-specific middleware that can be used by everyone. That's the vision for practical implementation.
Yeah, so that sounds like you have at least some ideas from all the engineering there. So that sounds nice. But you know that your model is not completely nice.
I mean, yeah, nothing is perfect.
So you need some it'd be nice to look at the MARSA and my set list to see.
Yes, that's actually a point that the team asked me to point out.
Yeah, as you said, it would be very good, if students from the university college could have a look at that. I mean, we're really encouraging that very much. So if you could put together a thing of some student projects or this, that would be very, very interesting indeed.
As you may have seen on the team slides that have been swimming in the breaks, the MARSA exists somewhere, so there is a place you can go and download the whole thing and see what it's like.
Repository, but I was also expecting some models popping up somewhere, but we didn't have internet to check that.
Okay. Any additional comments?
Just a short comment on that. I am now specifying the DP system of ours with what I would call an expansion of UML. It's more like SysML, but it is even more because at the Institute of Telematics we have made enhancements to UML, new modeling languages and so on. So and it's quite revealing, because when you do a model of a huge complex system, you force the software engineers to think about those things they hadn't thought about. So you force people to think about interfaces and this and that and everything. It's quite quite fun actually.
Sorry, I make you move. Question that came to me, triggered by a couple of things over the last 2 days. I've been involved in the autonomous car project that Google does, and personally I'm convinced that all the efforts to bring brains into one car and optimize security and all these things will bring you to a local maximum, but not to an overall best situation. The big step forward will be when you start allowing these cars to communicate and exchange and then optimize on that level, because collisions would be negotiated the way. You don't have to see the car coming. As a driver, the cars will negotiate who goes over the intersection first, etc. So yesterday we had the comment about the very thin bandwidth of communication between offshore and onshore. But today we heard about simulations, and these simulations are about multi-agents, but not autonomous in the way, but controlled remotely by people on either part of that, being able to communicate. Is there any thought in this world about extending the communication of the vessels and then having simulations on the next level of how do these vessels talk themselves through problem situations? Or is it just so far out there that we talk next year about this?
Yeah. Wow, that was an alarm actually. Wake-up call, let's say. We are working with simultaneous operations at sea and trying to simulate lots of actors working simultaneously and independently. I think the method of solving collision avoidance for cars, I think I calculated that out had an example of that back in 1979. So the cybernetic calculations are easy in a way. To put that into product is something quite different, and all these simultaneous operations that are going on, where we have just scratched the surface. Of course, I can't say scratch the surface about something going on the water, but you get the gist of it. There is so much to grab there, so there will be a lot of work for students, graduates, whatever. So much more than I think people can imagine, especially on that too.
And I would actually argue we should try to cross-fertilize a bit from other domains. I mean, there's absolutely no reason that what's done in the automotive domain or avionics or any other field shouldn't be adopted or tried out in the marine field, because we have this stovepiping tendency. We try to say, oh, it's water involved, so it's different. That's absolutely not true all the time. There are specific domain characteristics, but we know that there are research projects on the way now for in specific marine difficult sectors where collision avoidance is an absolute must. The installations, if I may call it that, or ships or floating objects will not be allowed to be built if they are not more or less 100% collision proof. And since it can be done in space and it can be done in cars, why not look at those technologies and see how we can integrate it? There's no reason to reinvent the wheel.
The marine industry is way behind a lot of things. But there's one place where we did okay, and that is at AIS. We do know where the ship is, where it's going, and what its intentions are. And yes, there are research projects going on to even automate decisions on collision point based on what we know of what the ships around you are doing. It's low bandwidth. It's 19.2 kilobits per second. That's it. You can do a lot with AIS.
Anything else? I guess that's it. Thank you very much. We have one speaker left, and then we're having networking lunch. Thank you.